Here we're also looking at the Earth like this. So the Earth is pointing its axis towards you. So here's the North Pole coming at you right there. That's what we're looking down. So North Pole is over here. North Pole of the moon is close to here too. So that's the angle that we have. That's our viewing angle. And so we have sunlight coming from the left side. And before you draw anything, if you want to draw the circles, you could probably use a quarter. That's the easiest thing to do. Just use a quarter. Nickel is too small, but a quarter is fine. So I was going to prove to you guys that the moon does rotate. This is the proof that the moon does rotate. However, because always faces one side towards the Earth, it appears as though it's not rotating, but in fact, it is rotating. So don't do this though. Let me just do this, and then you guys can just watch me. So I'm going to set a flag here. The flag is pointing at the Earth. Let's say the astronauts set a flag on the moon a long time ago, 1969. And we're going to set that flag to point at faraway galaxy here. So this is a faraway galaxy. It's not going to move in a million years. So this is a reference point. The flag is pointing at the galaxy. If the moon did not rotate, then that flag should be pointing at that galaxy, like this. And if the moon did not rotate, we should be able to see both sides of the moon. The side that is closest to us and the side that is farthest from us. So that's not the case. We don't see that. What we see is that the flag itself is rotating. So here's the flag. Flag is like this. Flag is always pointing at the Earth. This is the actual situation where the flag is always pointing at the Earth. So the flag is rotating. If the flag is rotating, then the moon should be rotating. So why is it that we don't see both sides? Because the revolution and rotation of the moon are synchronized exactly the same time, like 29.5 days. So in 29.5 days, the moon rotates one time. It also goes around the Earth one time. It's called locked into orbit. So this baby is locked into orbit. All right. So since the light is coming from the left side, everything is going to be lit. Half the Earth is going to be lit, half the moon is going to be lit, and half the Earth and the moon are always lit anyways, right? So if this was the moon, let's see, if this is the moon, it's going to be lit. Half of it is going to be lit. So there it is. Half the moon is lit, right? You can see that. Half the moon is always lit. Now, how much of that you can see, that constitutes the phases. Like here, you have a crescent. Here you have a quarter moon. Here you have a gibbous moon. Here you have a full moon. Gibbous, quarter, crescent, new moon, no light. All right. So let's do it. I'm going to put sunlight on the moon and the Earth. So let's put sunlight on half the moon and half the Earth. And so the way I do this is by shading for sunlight. So sunlight is going to be just shading like that. So I'm going to put some shading in here. That's sunlight. And we also put some on the Earth too. There you have it. Now we have sunlight on the moon and the Earth. Now the question is, if somebody's on the earth, let's put some people on the earth. Like this little green people living on the earth. When they look at the moon, what do they see, right? What part of the moon would they be able to see that's lit by the sun? All right, like that, all right? So let's see, how do we figure that out? How much moonlight, it's called sunlight really, is visible to these guys on Earth? How much of the sunlight do they see? How do we figure that out? Well, the one way to do it is this. We draw a line from the center of the Earth to the center of the moon, like this. We go center of the Earth to the center of the moon. Center of the Earth to the center of the moon. It doesn't have to be perfect. Now, if I draw a perpendicular line like this, this will tell me how much sunlight on the moon is visible from the Earth. And that is something that I'm going to crosshatch. So crosshatch, shading. Shading is light. Crosshatching is going to show us how much of that sunlight is visible from the Earth, because that's going to be our phases. So we can see this much moonlight from the Earth. We can see this much moonlight from the Earth. So what do they look like? Well, if I look at this guy, he sees nothing. This is a new moon. There's no light. So that's the new moon. This one here, well, I can see that much. It looks like a pizza, but really it's not a pizza. It looks more like this. It's a crescent. So how does that make sense? Why do I see a crescent and yet here I see a little pizza? What's the deal? Well, the deal is I'm looking at the moon like this. And so the pizza looks kind of like this. That's what I'm looking at, right? When I look, this is what I see. Like that, right? That's what you're looking at. So when you see this, you see, or you see this, you see like a little triangle. But now watch what happens. If I don't cut my finger off, I should be able to do this. I'm going to cut a slice here. All right, so when I remove this slice, now I see. So from one angle, it looked like a triangle. From this angle, it looks like a crescent. Triangle, crescent. Crescent, triangle. Just like that. Is there any questions here? So if I put it together, it looks like our moon again. Like that. If I take it off and look at it from the side, it looks like a crescent. Like that. All right. Okay. So let's finish it off. This guy here looks like a quarter moon. Like that. This guy here, we draw a line from the center of the moon to the center of the Earth. Perpendicular line. We see almost all of it. Like that. What does it look like? Well, it looks like a 3/4, like this. All right, like that. This guy here is going to look like a full moon. So we have the new moon all the way to the full moon. All of these phases here are increasing in light. The moon is getting bigger and bigger and bigger. We call all these phases the waxing phases. These are the waxing phases. They're the waxing phases. And then they're going to get smaller and smaller. Full moon. Okay. You can see all of the light on the moon now. From this little guy's vantage point, he's looking at it, he sees all of this. This guy here can see about 3/4 of it. This guy here sees 1/4 of it. This guy sees a little crescent again. So there you have it. I'll just draw the rest of these. So after the full moon, we're going to have a gibbous. Like that. And then we're going to have the 1/4 here. After the 1/4, we're going to have another crescent. Like that. So we have our phases. We're going to put the names on there now. And after we put the names, we're going to get the elongations. So these phases here, they're going to get smaller. We also call these phases waning. Waning, we read as waning. Waning phases and waxing phases. So this one here is called Waxing Crescent. For 7 days, we're going to have a waxing crescent. So waxing crescent. First 1/4. This is going to be a waxing gibbous. Now, after the full moon, we're going to have all the waning phases. So this would be a waning gibbous. Third 1/4. I have no idea why they call it the third 1/4. Somebody figured out this is the third 1/4. It could have easily been the fourth 1/4. I don't know. All right, so this could be a waning crescent. Waning crescent. Now we're going to get to the elongations. So I'm going to give you some time to finish this first. When you're done drawing it, then I'll get the elongations. I don't want you guys to miss the elongations. I want to make sure you guys get the elongations. Well, before we get the angles, let's just for a second look at the moon people. See, if you were on the moon or Selenites on the moon people, what do they see if they look at the earth, right? So if you were the Selenite here, they have horns, very short legs. Selenite, they live underneath the moon. They live inside of the moon. Okay, now this guy looks at the earth. What does he see? He sees a full earth. So from a new moon, Selenite looks at the earth. He sees the full earth. Selenite looks at the earth from the full moon. What does he see? A new moon. Selenite, let's see, from the waning crescent moon, looks at the earth. What does he see? Anybody for a point?
Waning quarter.
Waning, there's no such a thing as a waning quarter. So from a new moon, the Selenite looked at the earth. He saw a full earth. From a full moon, he looked at the earth. He saw a new earth. There's no light. From the waning crescent, he looks at the earth and he sees.
Is it a waxing gibbous?
Waxing gibbous. And that sounded like Perry.
It was Jasmine.
Jasmine, yay. You sound like Perry. Jasmine, what's your last name?
O'Clancy?
I'm sorry? How
O'Clancy?
do you spell that?
O''CLANCY.
Thank you. That's right. Excellent. She's absolutely correct. So all you had to do was to look across here. Waxing gibbous earth. So from a waning gibbous moon, we look at the earth. What do we see? We see a waxing crescent earth. From a waxing gibbous moon, we look at the earth. What do we see? We see a waning crescent earth. So you just look at the opposite side and read the moon's phase and attribute it to the earth. That's all. Full moon, we see new earth. New moon, we see a full earth. Waxing gibbous, we see a waning crescent earth. First quarter moon, we look at the earth, we see a third quarter earth, like that. Exactly the opposite, all right? Okay, is everybody finished drawing? Can you guys give me all the attention now? This is not
Yes, I'm done.
I'm sorry, you're still doing it?
I'm done.
Everybody else is good? Okay, so now I'm gonna go. So now, here's the way we do it. From the earth, we look at the sun, we look at the moon. In this case, there's no angle between them. This is 0. There's a 0 degrees. So the elongation of the new moon is 0 degrees. So we got down 0 degrees for the elongation of the new moon. What about the waxing crescent? Let's take a look. Let's see. So here we have the sun. From the sun, we go to the moon. What is this angle here? This is a 90-degree angle, right? This appears to be half of 90 degrees or
45.
45. That's right. It's 45 degrees. So there you have it. This is a 45 degrees. Now, I don't know if you guys recall, we said that the waxing phases are east of the sun. So when the sun is setting, waxing crescent is going to be pretty close to the sun. It's going to be about 45 degrees above the sun. So you see, this is the moon that you see at night. Like if you go out early at night, right after sunset, this is what you see. So this is 45 degrees east of the sun. That's the elongation. And then here we have from the earth, we look at the sun and we look at the moon. 90 degrees. And since it's a waxing phase, that's a 90 degrees east of the sun. So 90 degrees east of the sun is the elongation here. What do you guys think about the waxing gibbous? What do you think this angle is? So we go all the way from the sun, all the way here. What is this angle?
135.
135, that's right. Excellent. Who said that?
Cyrus.
What's your last name?
Cyrus Hosseinifor.
Oh, Cyrus. Okay. All right. Thank you, Cyrus. I'll give you a point for that. All right. So this is 135 degrees east. And then 180 is just the full moon. This is the full moon. Remember, when the full moon sets, the sun rises. When the full moon rises, the sun sets. So they're 180 degrees in the sky. One of them is over here. One of them is over here. So this is a 180 degree angle, right? Put this down for a second. So 180 degrees, that's a 90 and a 90, 180, right? So this baby here is 180 degrees. That's the elongation here. Okay, what about this guy here? Now all the angles are going to be west of the sun. So when the sun is in the sky, the moon is west of it. It's just like rising. So waning gibbous is going to be 135. But west of the sun on the other side. So this is a 135 degrees west of the sun. Again, 90 degrees west of the sun. And finally, 45 degrees west of the sun. There you have all the elongations now. So you're going to be referring to this diagram for all your work. Everything that you do, you have to go back and look at this diagram. So you go, okay, so what's 45 degrees east of the sun? Waxing crescent. What's 135 degrees west of the sun? Waning gibbous. What's 90 degrees west of the sun? Last quarter, third quarter, right? Like that. So you're going to be using this diagram all the way throughout doing your lab. So I'm going to let you guys finish this, give you a couple more minutes to finish it. Then I got to erase it so that we can get to the lab itself. Basically, this is your reference. Is there any questions you guys want to ask before I sit down and show you guys the lab? Okay, I guess you guys are good. Let me see if I can sit down and show you guys. The lab. All right. All right, so lab really starts over here. Although you're gonna finish this, right? You're gonna finish this. You're gonna give this to me too, just like I did here. So we're gonna go now and take a look at the lab. So you're gonna have a whole bunch of situations like this. This is your horizon here, right? This is south, north, east, where things rise and then things set. Let me get the little spotlight. All right, so things rise in the east. They go up, up, up. They reach the meridian, highest point in the sky for any object. Then they're going to set in the west. Then they're going to go below the horizon. And they're going to go all the way here and rise the next day. So this is how the moon and the sun are going to appear to move for us in 24 hours. All right, so here it is. Here's the sun, I guess. It could be the moon too. That's the moon, actually. The moon is rising here. Here's the sun here. Two things are going to probably bother you. One is figuring out all these angles. That's going to be kind of tough. One is going to be the time. So let's get the time first. So make yourself a time diagram, where in your time diagram, you can figure out time. What time is it? So time can only be told by the position of the sun, not the moon, but the sun. So if you can see the sun, you can kind of tell what time it is, as long as you know your directions, like south and north and everything. So if the sun is over here, 12 noon. Sun is rising, 6 a.m. Sun is setting, 6 p.m. Sun over here, 12 a.m. What time is it here between 6 a.m. and 12 noon? 9 a.m. What time is it here between 12 noon and 6 p.m.? This is going to be
3.
3 p.m., right? 3 p.m. So then sun sets at 6 p.m. Midnight. What's between 6 p.m. and midnight?
9 p.m.
9 p.m. And then make yourself a little fun thing here. This is going to be midnight, 6 o'clock in the morning. So that's going to be
3 a.m.
3 a.m. That's right. Man, that orange is making me cry now. Sheesh, man. Yeah. Jeez, man. Stuck my finger in my eyes. Wow. Strong orange. All right. So the position of the sun gives you time in these diagrams here, right? So let's take a look real quick. What time is it here?
Three a.m.
Very good. That's 3 a.m. So that's the time. So you write down 3 a.m. in your timeline. What time is it here? We see the sun.
6 p.m.
Very good. That's right. So now here it doesn't tell you where the sun is. So, but it gives you the time. It says it's 6 p.m. So if it's 6 p.m., then the sun is going to be here in the west, right? Right here. That's where the sun is. Now, let's see. Here it says, all right. It says moon's position, and it says the moon's position is rising. And it actually has the moon rising here, right? Okay, that's good. Everything is rising in the east. So it's got that. Here it says setting. But there, I don't see any moon or anything, right? So when it says setting, take advantage of it. Put the moon right here. And then it says midnight. So the sun goes over here. So the sun is over here. The moon is over here, setting. It says the moon's position is rising. So you put the moon in the east here, look over here. Now here it doesn't say the moon is rising, setting, nothing. I don't need you to do anything here. It's not a contest. The moon, I guess, is, what would you call it, about to set in 3 hours? It's ridiculous. So we don't need a moon's position here, all right? So if it doesn't give you the moon's position and request the moon's position, it's up to you. If you want to put it in, fine. If you don't want to put it in, fine. But when it says it's setting, like here, then stick it in the west. Let's see. Here it says it's in the east. Moon's position is in the east, so stick it here in the east, right on the E. Let's see. Here it says west. Stick it on the W, west. Setting, stick it right here. Setting, stick it right here. 10 p.m., this makes it a little more complicated. We don't need complications tonight. You can just skip question O altogether. Just cross it out. We don't need to do that. We don't need no stinky O question. So here again, setting, rising, so you know exactly where to put the moon. So this is the moon's position. Then we get to the elongations. So when you do the elongations, that's going to be your tough job. Elongations and the phases. That's going to be tough. So let's see. That's what I'm going to do for you right now. I'm going to show you how to do the elongations. And the elongations should give you everything. Now I'm going to ask you guys to read me something. How about something that is more difficult? Let's say this one here. This one here, J. I'm going to put somebody in charge of reading J. Who's got the lab? Angel, do you have the lab?
Yes, I do.
Okay, when I get on the board, read me this question, all right? And
Okay.
also, let's see if there's another difficult one somewhere. Yeah, this one here, N. How about J and N? All right.
Okay. J is. Oh, you
J,
ready?
John
Okay.
Nunez. All right. This is a Superman. All right. So let me get on the board. We'll do this for you. Let's see. How do I stop sharing now? This is a fun part. I guess I got to kill this before I stop sharing. There we go. All right. So I'm going to erase this. Is there any objections to me erasing this? I know it took me half an hour to draw it. Now I'm going to erase it. So I'm going to erase it real quick. Okay. All right. So what do we got here? We got a horizon, right? So they give you a horizon. And on this horizon, you have the sky on top of your head. And then you have the east. Things rise. West. Things set. South. North. And I'm going to have something rise. You guys to the meridian. This is the meridian. It's up and then it sets. After it sets, it goes below the horizon. And it rises again the next day like that, right? Okay. So let me put a sun someplace. So I'll put the sun over here. What time is it over here? 12 noon. 12 p.m. What time is it over here? 6
a.m.
p.m. That's right. Here, 6 p.m. Here, 9 a.m. Here, 3 p.m. Here, midnight, 12 a.m. Here, 9 p.m. Here, 3 a.m. All right, so if they say it's 3 p.m., you can just stick it at 3 p.m., all right? 3 p.m. As soon as you see it at 3 p.m., you go, okay, that's where it is. That's where the sun is. You know exactly where the sun is. If you see the sun in the diagram with nothing else, just see the sun, go, okay, it's 12 noon. It's 9 o'clock in the morning, so you can get the time. So the time gives you the position of the sun. The position of the sun gives you time. Does that make sense? So you can get that fairly easy. So this is your time diagram. All right, now the tough one. We're gonna do elongations. How do you do the elongations? So let's do a big one here. I'm gonna do a big one. Go. Ready. There we go. All right. So now imagine there is this blue guy standing here. Here's a little blue guy. All right, you guys see that blue guy there? So it's all from the vantage point of this little blue guy here. So that blue guy sees east, things rising, west, things setting. This is going to be the meridian. This is going to be south. This is going to be north. And now, I'm going to put a little cross for you guys here. So the cross is going to be kind of like this. Let me actually draw it out for you. All right. Now I'm going to do this. Okay, so the angles appear to be all screwy, right? Why is the angle screwy? Because what we're looking at, so this little green thing here, right? This little green thing with things rise and set is really a circle, right? It's a circle. Things go up, keeps coming down. Go up, keeps coming down. Like this. Right? Like that. Except here, everything looks easy. You can see this is 90 degrees. This is 90 degrees. This is 90 degrees. This is 90 degrees. Now, what happens if I tilt it, right? So if I tilt it, what happens to it, right? There's a circle. What happens if I tilt the circle, right? If I tilt the circle, I get this now. So it's a circle that is tilted, and it's kind of, you have to get used to this. This is 90 degrees. This is 90 degrees. This is 90 degrees, and this is 90 degrees. 90, 90, 90, and 90. So you still have 490 degrees. And half of that is going to be 45 degrees. So if I'm trying to get this angle here, say to here, so this angle here is 45 degrees. And so if I go from the sun is here setting, there's the sun is setting, and the moon is in the sky, say over here like this. I should make it realistic. There's the moon over here. So what's the angle from the sun to the moon? It's always from the sun to the moon. So what is this angle? We're trying to go from the sun to the moon. What is this angle? When you see this, then my job is done. I'm gonna say good night to each other. So let's take a look. So the sun is over here on the horizon. Something is in a meridian, that'd be 90 degrees. So this is 90 degrees plus 45, 90 plus 45, 135 degrees. So this angle here, it is 135 degrees. Now, as you can see, this is east of the sun. It's easy to see here, but what if the moon is not here and someplace here? It's not going to be so easy to see. So I'm going to give you a prescription on how to do the lab. I'll write it down, you guys read it and see what you think. This is the way you should do it so you can get all the angles and everything correctly. So let me do this for you. I'm going to say, always, right? Always go from the sun to the moon counterclockwise. Counterclockwise is this way. Counterclockwise is the opposite of clockwise. So you always start going counterclockwise first. Counterclockwise is this way. So this is CCW, counterclockwise. The clock goes this way, counterclockwise go this way. So you always start from the sun, go counterclockwise. 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 If you find the moon within 180 degrees, comma, it is east of the sun. If not found within 180 degrees, then go clockwise. Clockwise. And this will be west of the sun angle. So west of the sun, east of the sun. That's how you figure out east and west. If you find the moon within 180 degrees of the sun going counterclockwise, you found an eastern angle. If you don't find it within 180 degrees, then you go clockwise. This moon is going to be west of the sun. Okay, write this down, I guess. And then Angel is going to read me a couple of questions that I'm going to do for you guys as an example.
Is that last part the sun angle?
Huh?
The last part is, it will be west of the sun angle?
Yes, you have that information on the drawing that we did at first.
Yeah, I see it.
Yeah.
I got the drawing.
Yeah, if you look at the drawing, it tells you what all the phases are.
Yeah, I see it.
That's it. All right, so let's see. So I guess I will ask somebody to help me besides Angel. What if I asked, let's see, since you don't mind, maybe I can ask you, Gerald. So Gerald, see if we can figure these out, all right, as we do it. Can I erase?
Okay.
Yeah, I'm going to erase this now. All right, so I'm going to erase everything. I'm going to draw what Angel is going to read me. Angel, are you ready? I think we're going to do J, are we? Is it J?
J.
J? Okay.
Okay. The elongation of any object in the solar system is its angular distance measured from the sun to the object.
Wait, what are we doing here? I'm sorry.
No, not
No. Angel,
J.
you're going to read me the actual question, right? Do you see?
No. Oh, like what it's.
J, the actual question. I can do it for you. Do you
You
see it?
just. I don't see a question with J.
Okay, if you don't see
That
it,
was.
yeah, go ahead. I'm listening.
Then maybe you can tell me what page.
What page? Let me see. It'll be page 5, I think.
That has A through I.
Okay, then go to the next page, 6.
Okay, you just actually had it written up there, I thought.
Yeah, they're
Okay,
all
the
same,
the
right?
moon position is east.
Okay, so let's draw this out. So the moon's position is east, right?
And the elongation is 135 west.
Okay, so the angle is what? 135 degrees?
The elongation, yeah, 135 west.
West, okay. And the moon is rising. That's the information that we have, right? That's it?
Yep, that's it.
Okay, so the moon is rising. Here's the moon rising. Here's the moon is in the east rising. And it doesn't say what time it is, right?
Nope.
Okay, so we got to figure out where the sun is now. All right. Well, let me see. Let me draw all this out now. But maybe I should move this a little bit. Get it a little fancier for you. Okay. All right, so there's 2 places they're going to be 135 degrees from the moon. One place is going to be right here. That's one place. So the moon is 135 degrees from the sun. So from here to here is 45 degrees. From here to here is 90 degrees. And so there's 135 degrees here. Or I can put the sun here. And in this case, this is going to be 45 degrees. And this is going to be 90 degrees. So either way, 45 and 90, 135. 45 and 90, 135. So we're looking for 135 degrees west. So now, would you please read your instructions and tell me which one of those suns is the correct sun? 1 or position 2? Which one of these should the sun be at? Because this will determine time. Position of the sun. 1 or 2?
1.
1, okay. So what does it say? 135 degrees west, right?
Mhm.
Gerald, if this is 135 west, read your instructions again, please. What do the instructions say? Are you reading it? It says start from the sun, right? You go counterclockwise first, right? And this would be east of the sun, correct?
Right.
Okay, so here's the sun. You said this is the correct one, right?
Yeah.
Okay, so I'm gonna go counterclockwise and I see the moon within 180 degrees. So that can't be right, because if the moon is over here and this is our sun, this will be 135 degrees east of the sun. We're looking for 135 west of the sun. That's why I did this one. This is the most difficult one of all of them, right?
Mm.
Okay, so if I go this way now, this angle is going to be west of the sun because I'm getting to it going clockwise. Clockwise?
Oh, I see it.
You see it?
Yeah.
Clockwise? Counterclockwise. CCW. So
And that would be
clockwise,
waxing.
right? You gotta go clockwise. So clockwise angles are west, counterclockwise angles are east. So then what time is it if the sun is in 2? So this is incorrect. This is correct. So you put your sun here. What time is it here? How do you get the time? Take a look at
9 p.m.
9 p.m. Very good. So your time is 9 p.m. So fill in your time. 9 p.m. We know the angle here. What is the phase? Look at your general diagram. What is the phase for 135 west?
Third quarter?
135.
No, I'm sorry. Waning gibbous.
Very good. No, you don't have to be sorry, by the way. It's all right. Okay, so it is waning gibbous. All right, so let's do the other one that we talked about. We said it was J and what else? 1, 2, 3. Fourth one from J. What is that?
M.
So you go J.
You said O.
Oh, okay. Oh, yeah. Give me O, please.
Actually, you said.
Oh, you said not to do O.
Yeah.
Oh, not to do O. My bad.
L. And
It's the one before O. What is the one before O?
and
I'm sorry?
N.
N. Okay, give me N, please. What does N say?
Moon position is setting.
Okay.
Elongation is 45 degrees
45 degrees
Uh,
what?
west.
West. Okay. All right. Does it give you any pictures at all? Is there any information at all?
Nope.
Nope. Okay, great. We got everything we need. All right. So let me get everything here. So we go, okay, so things rise here in the east, set here in the west. Here's the south. Here's the north. Things rise here. Then they go down below the horizon. Then they come back up here. And we said setting. The moon is setting. So where the heck is the moon then? If it's setting, it's right here. Here is the moon. And now we got to put the sun someplace where we can go from the sun to the moon 45 degrees clockwise. Where would that be? Where do we go from the sun to the moon clockwise? Well, it's either here or here. This is a 45 degrees. So this is 45 degrees. This is 45 degrees. One of them is going to be clockwise. The other one is going to be counterclockwise. Let's call this position 1 and position 2. So which one is true? 40, the 1 or 2?
2.
2. Okay, so from 2, I'm going to go to the moon counterclockwise. That's not what you want to do, right? Counterclockwise is east. We have a west angle, 45 degrees west of the sun. That means we got to go from the sun to the moon clockwise. As soon as you see the W, you want to go from the sun to the moon 45 degrees clockwise. Clockwise, right? Clockwise. West, clockwise. So then clockwise will make it this guy right here. So this would be wrong. This would be correct. So what time is it?
3 p.m.
3 p.m. And what is the phase? 45 degrees west. What would the phase be?
Would it be a waning crescent?
Waning crescent, that's right. So it'll be waning crescent, and the time is going to be 3 p.m. Okay, so I guess the last thing I'm going to do for you, I'll do one more diagram, and I'll give you examples, I guess. Let's see if you guys can still see it. All right, so east, west, south, north. Like that. Let's put the sun over here. All right, there's the sun. Now I'm going to keep changing the moon, and you guys tell me the angle and what the phase is. All right, I'll keep changing the moon. So what if the moon is rising here? What is this angle?
Wouldn't it be 90 degrees east?
90 degrees east. That is correct. Very good. Why did you say 90 degrees east? Would you please explain it to everybody else?
Because it's the moon in relationship to the sun is counterclockwise.
Very good. So from the sun, you go to the moon counterclockwise. This is counterclockwise, right?
Yeah,
Counterclockwise.
you would go over 180 degrees if you tried to go clockwise.
That's right. So this is 90 degrees east. Now, why is it 90 degrees? Because this is 90 degrees, right? We did that. 90 degrees, 90 degrees, 90 degrees, 90 degrees. 360 degrees all the way around you, right? So if you go around you, it's 360 degrees. So you're looking at the moon over here, the sun is over here, or vice versa. The sun is up here, the moon is over there. So therefore, 90 degrees, and you have to go from the sun to the moon Counterclockwise, so it's an eastern angle, counterclockwise. All right, let me move the moon somewhere else now. Let's see what you get now. Let's put the moon over here. All right. What's the phase? What's the elongation?
180 degrees, and it'd be a full moon.
Very good. That's it. Yep. It'll be a full moon because 180 degrees. And so you know the phase, you know the time, you know the elongation. All right. Let's put the moon somewhere else now. How about if I put the moon over here? Over here.
Is it 45 degrees west?
What is the elongation?
Is it 45 degrees west?
45 degrees west. That would be correct. And then what is the 45 degrees elongation? What's the phase?
Waning crescent.
Very good. Waning crescent. There you have it. All right, so let me put it some one last place here. Let me kill this guy and move it. By the way, you guys can go over the videos over and over and check it out if you need help. Okay, so I'm going to put the moon here now. What's the elongation of this guy?
135 degrees east.
Okay, 135 degrees east. And what is the phase?
Waxing gibbous.
Excellent. That's it. You got it, man. You got it. Now, who's answering all these questions?
I answered the last two.
And who are you?
Jackson, Kennedy.
Kennedy. Thank you, Mr. Kennedy. I'll give you a point for that too. Thank you very much. Good job. All right. So you guys, if you forget all this stuff, you can watch it on the video. And don't forget the horns of the moon. And oh, by the way, let me give you the last couple of things here. So here's the moon, right? And let's say here is the sunny part. So this is moonlight, right? There's moonlight. Now these are the horns. One horn, second horn. They point away from the sun, right? All right, now there's a line here between the dark part of the moon and the light part of the moon. If you have a telescope, that's the best place to look at it. Now, by the way, I'm going to tell you guys the update on the telescope too. So that area here between the light and the dark is called terminator. Terminator. Arnold Schwarzenegger. Terminator. All right. Now here, there's a little bit of light. There's a little bit of light, right? There's a little bit of light here. That's the light of the Earth on the moon. We said you could read newspapers at night. It's 100 times brighter than the full moon. So this is moon. This is Earth light. Earth light is called Earth shine. Earth shine. Earth shine makes the moon look so much more beautiful. So when you have a crescent moon, you can see not just the crescent, but you can also see the dark part. It's got some light. That light comes from the Earth. That's Earth shine. All right, now this is also called the limb of the moon. The limb of the moon. So the edge of the moon where there's light, you say that's the limb of the moon.